the content in open session, and then we'll discuss the doubts from solve with the same thing. Okay. So what's the idea? So is will it be all right to everyone? I will summarize the concepts of week 2 content. Will
Yes,
that
sir,
be
that will be helpful.
absolutely fine?
When the ask was doubt.
You can ask after the end of the once I will complete the concepts. You can ask the doubts. That will be fine. Okay,
Okay, sir.
fine. Yeah.
So,
Yeah.
i- is it Prashant too?
Yes. Yeah. It's Prasant too.
Okay. Thank you, sir.
Yeah. You can on this course, right?
Yes, sir. Yes, sir.
Yeah. Okay. Fine. Okay. So let me share my screen. We'll start the concepts first, and we'll discuss the some content, and then we'll move to the doubts. Okay. Meanwhile, one general question before that: is the TA session and all is going well?
Yes, sir.
Okay. Fine. Fine. So you guys are asking the doubts from
We are not able to access the TS section zone.
TS. You can simply click. Can
No,
you please?
the recording.
Which thing? I mean, which
And they
session?
haven't given the access.
Okay, okay, no problem. I will check. I will check the recording access and all. Don't worry. After the end of the session, I will check and I will give the access. Okay, don't worry.
Yeah.
Sir, how can I access this session?
It's live on YouTube also. You can access from the YouTube. Okay.
Sir, can you
Meanwhile,
please send me the
I'm
link?
pasting the YouTube link here in the chat box. You can access it later also, and I will update on the calendar itself. Okay, so you can find the YouTube link from the calendar itself. Okay, so there are several ways you can find. I mean, you can watch, rewatch it later as well. Okay.
Sir,
Yeah.
what to can do in week activity 3?
Activity three.
What to do?
You have doubt from activity three.
Yeah, sir. I
Okay, so
don't.
basically, Vivek, this session is basically for week 2. Okay, let's discuss first week 2. Okay, if we'll have it timing, we can discuss week 3, or else we will be session for week 3 as well. Okay, don't worry.
Okay, sir.
Okay, fine. Yeah. Okay, so will that be all right? Should we start with the concept? Okay.
Yes, sir.
Okay, no problem. Okay, so I have shared my screen. Is my screen visible to all of you?
Yes,
Yes,
sir.
sir.
Yes, sir, it's visible.
Okay, fine. Thanks. Thanks for the confirmation. Okay, so in week 1, what are the things we have discussed? We saw some, joint PMF of two discrete random variable and all, right?
Yes, sir.
So I'm writing DRV for discrete random variable. Okay. This joint PMF, what are the properties to be a valid joint PMF and all? Okay. Then we saw the marginal PMF and all. Yes or no? Right?
Yes, sir.
Marginal PMF, conditional PMF, correct?
Yeah.
And so on, so on. Now, in week 2 onwards, we will see from week 2 onwards, we'll move some one step ahead. So, what's the next step in week 2? So, how I can identify my two random variables, let's say x and y are independent or not. Okay. So, we'll see independence of two random variables. Okay. First of all, in week 2, we'll see independence of two discrete random variable. So mainly we will be focusing on discrete random variable. After that, we'll move to the, I mean, from week 4 onwards, we'll be moving for the continuous random variable. Okay. Then after independence random variable, independence of two random variables, we'll see independence of multiple random variables. Then IID trials or IID random variables. Okay. Then we'll move to the function of random variables. Okay. I think these are the major concepts of week 2. Or yes or no? I mean, after independence, After two random variables, we will be moving for multiple random variables. Okay. With the same concept, then we will move. We will see what is the meaning of IID. Then we'll see. Let's say see we have two randoms. We'll see maximum of random variables. Then minimum of random variables. Okay, and then function of random variables. Okay. So these are the major concepts we will be covering in today's session. Okay, let's see. Let's move to the independence of two discrete random variables. Okay. Okay, before going to discrete random variables, let's come to the event with the concept of event. So you guys have seen in stats 1 and all. Let's say I have two events A and B. Suppose these are two events. So what is the condition or when you will be know these two are independent?
If the
So
union,
probability of A intersection B is equal to probability of A multiplied by probability of B.
Correct?
There has to be an intersection essentially.
Intersection, right? So basically, this is the condition for being a independence of event. But these things, how come? Any idea?
from the conditional thing, we get this.
Correct. So see, independence means what? See, dependence means suppose I'm going to change in one event or one random variable, the effect of there is a effect of another also, right? Independence means so it's a simple concept happening or non-happening of an event doesn't not affect the another event, right? That is the meaning of independence. Yes,
Yes,
or no?
sir.
B, this means B complement. Okay, whether B is happening or B is not happening, there it should be equal to probability of A. Then I will say it's independent. By using this concept, we know what is the probability of A given B. Probability of A intersection B divided by probability of B. Yes or no? So from
Yes.
here, I can say probability of A intersection B is nothing but probability of A given B into probability of B.
Yes.
Yes, sir.
Correct? And we know if it's independent, then this should be equal to probability of A into probability of B. Yes or no?
Yes, sir.
So
Yes,
this
sir.
is the condition for independence, right?
Yes. Yes.
It's clear.
Yes.
Now come to the part of random variables. So suppose I have two random variables x and y. Okay, two discrete random variable. Let's say x is taking. I mean, there is some range for x. Let's say denoting as tx, for y denoting as ty. So tx means set of all possible values which I mean where my random variable x can take, and this is the set of all possible value which y will take. Okay. So these two will be independent if by using this concept, can you tell me the joint PMF of these two should be equal to product of their
Marginal.
Marginal
marginal.
PMF.
Is this clear?
Yes,
Yes,
sir.
sir.
Okay. And where is a simple? So T1 for basically x1 and T2 for x1. So T1 should belongs to Tx and T2 should belongs to T. It can be anything T, P dash. Let's say I'm saying fx of I can simply say fxy of a comma b, where a belongs to Tx, b belongs to Ty. Doesn't matter, but these are the some standard notation which we are going to use in this. Okay. Okay, so is this clear? Independence of
Yes, sir. Clear.
random variable, right? Okay. So now let's move to the now. So what thing I can interpret from it? Okay, so by using this concept, right? By using this concept, can you say something? See, as you can see, right? I can say, I can. If you see this content, can you say something? In the similar context, can you say fxy of t1 comma t2 will be same as fx of t1 into fy given x1 equal to t1 t2? Yes or no?
Yes, sir. We can say that.
I can say so, right? Or it's a simple concept by using the conditional probability. Yes or no?
Yes.
Okay. So as you can see, independence means what? Probability of A given B equal to probability of A, right? So same thing I can say fx. Let's say let's talk about in terms of y itself. So f y given x1, not x1, x equal to t1. Okay. So it will be x equal to t1 of t2. It should be equal to what? Fy of t2,
Yes, sir.
right? Means if I will be saying this conditional is equal to marginal of y, then I will say x and y are independent or not. Correct?
Yes.
Yes, they are.
So I can verify any of the case, whether this case or this case, right? Okay. So if x and y are independent, right? If x and y are independent, so there are two things I can say. Joint PMF is equal to product of their marginals, right?
Yes, sir.
Or conditional PMF is equal to the marginal PMF. Is this clear?
Yes, sir. We can say that.
We can say simply, right?
Yes.
Okay. Now, and it's a opposite way in reverse order. What will be if x and y are dependent? So simple, right? So joint of x and y, t1 comma t2, is not equal to fx of t1 into fx of. Is this clear?
Yes, sir.
Yes, sir. Clear.
No. So I think there is one thing you can simply verify. If joint is equal to 0, but marginal of those two is not equal to 0, it's simply dependent, right?
Yes.
Or
Yes.
let's say x, y, okay. For example, suppose this is the 0, this is the 1, and value is taken by, let's say, -1 and 1, for same -1 and 1, okay. So joint is 0 means what? This is the 0, right? Or suppose this is the 0.5, okay, and this, suppose this is 0.25, this is the 0.2. I think total is the 1, correct?
Yes, sir.
Correct. So here if you see, this is the dependent or not, how I will check? So if you
It's
see
dependent.
fxy of, let's say, if you see -1 and -1, this is the 0, right?
Yes, sir.
But
Yes.
fx of -1 is 0.5,
0.5.
and
Yes.
fx, sorry, y of
Minus
-1
one.
is 0.25,
Into
correct?
2.5.
Yes.
These two are not equal to 0, correct? I mean, sorry, one second. It should be equal to here for now. So this is minus fx of -1 is 0.5, fx of fy of -1 is 0.25. You say this is not equal to 0, correct? But joint is
Correct.
the 0. If this is the case, I will directly say this is actually one of the special case, you can simply say, right? Special case means if the joint is equal to 0, but the marginals are not. Marginal means fx of -1, this is 0.5. Fy of -1 is 0.25, right? Then this x and y will be dependent. Correct? And by the formula also I can simply check, right? Fx y of -1 and -1 is 0, but this is not, is the same as fx of -1 into fy of -1, right? By the independence criteria I can simply check. Any doubt till now?
No, sir.
No, sir? Yeah, thanks. So so in this was for the two random variables. What about more than two random variables? Okay. Now you can see if I have three events. Let's continue with the events. If I have three events, how will you check whether these are the independent or not?
So again, the multiplication of probability should be equal to A intersection B intersection C probability.
So this is the only case it should be true, or there are some other cases also?
So pairwise also I think should be there.
Correct.
There are even intersections.
So pairwise should be independent. Probability of A intersection B should be probability of A into probability of B. Then probability of B intersection C should be equal to probability of B into probability of C, and probability of C intersection A should be probability of
Probability of
C.
C
And
into probability of
so
A.
these are the pairwise independence, and this and the last condition should also. Then I will say A, B, and C are independent events. Okay. Suppose if suppose first three is not satisfied, only last is going to satisfy, then I will not say it's an independent, because all three are independent. It should be independent in pairwise also. Now the same concept I can use for the random variables as well.
Yes, sir.
right? So what about random variables? So for two random variables, I had, let's say I'm talking about x some n random variables. Okay. So for two, I had fxy of t1 comma t2. I had fx of t1 into fy of t1. Sorry, t2, right? Then f x1, x2, so on xn. Let's say t1 up to tn. So tn for xn, t1 for x1. Okay. So it should be equal to fx1 of t1 into fx2 of t2 marginal PMF of all these random variables, right? Including all the subset. Okay. Because there will be lots of subsets, right? 2, 3 intersections of and all, right? Then all the subset of independent random variables should be independent, right? I mean, this should be independent, correct? All the subsets. Okay, like here for three subset are A, B, B, C, and C, right? So for for A, B, and C, these three are the subsets, right? Similarly, here all subsets should be independent. So is this clear so far? Any doubt? So we have to just
No doubt.
extend for the three random variables, right? Okay. Now let's move to the IID. Okay. So far so good, right? Till independence, everything is clear to everyone.
Yes, sir. Clear.
Fine.
Yes, sir.
Thanks. So let's move to the IID. So what is the IID basically? So full form of IID is independent
Identically distributed.
and identically distributed. Okay, any one of you, do you have any idea why we are moving to the IID? I mean, and what does this mean, IID thing?
Like it's easy to
Same
calculate, and
marginal.
in real life we use this concept also, and it's
Okay,
easy to calculate as well.
okay. Is that only reason? In
Same marginals.
fine. So that's the property of IID, right? If IID, so marginal will be same and they should be independent.
Yeah.
So it could reduce our calculations. Means in past.
Bernoulli trial, sir. We find the sequence Bernoulli trial.
Okay,
And
so yeah, correct so far. So let me give you some idea that those are things we will be discussing in, I think, week 7, week 8 onwards. Okay, but I will give you idea for why we are taking the IID things. Okay, suppose you are going to do some yesterday, some analysis, let's say on rose plants. Okay, I mean, suppose you are interested to know the amount of time leaf of rose plants will take, something like that. Okay, I mean, any objective is there, any study is there for regarding rose plant. Now, suppose you had taken, so to conduct your studies, to conduct your analysis, you will be obviously taking the some samples, correct? Yes or
Yes,
no?
sir.
Yes,
So
sir.
Yes,
I
sir.
will create two scenarios. Just tell me which sample you will prefer. First sample, suppose I have taken some 10 independent sample of, let's say from a lotus plant, some lily plant, some any other some any other you can say flower. Let's say some uh, right now I'm not able to do. Let's say some 10 different flowers are there, right? I mean, you have taken the samples from 10 different flowers. Okay, to just do the your study. Now, in the second scenario, you have taken the samples of some 10 different rose plant. Those are independent. I mean, there is no dependency, but those are the 10 rose plants. Which sample you will prefer?
Second one.
Why not first one?
Because we are analyzing the rose plants.
We are analyzing the rose plant. That's okay. Why is the second one?
So because the chances of growing is same for each and every plant.
Okay, and so basically that's why the IID concept came into the picture. I mean, see, I want to do the study on rose plant, right? Then I will simply taking the samples of some, I mean, whatever numbers, let's say 10 samples, which are the independent and which are identical also, right? As per the my study and all. Yes or no? Are you getting my idea? Okay. So
Yes, sir.
that's why we are taking the IID samples. Okay, I mean basically accuracy will be more. See, this study you can do, but there, I mean the result of the study, we can't think there will be some accuracy or there will be some meaning of that result. Yes or no?
Yes, sir. In second case, it is far more accurate than the
Correct. So
first
that's the
case.
meaning of independent and identical. All those things should be independent and identical means that should be the same. Now, the same concept you can use for the random variables. Suppose I have some, and suppose if I will say x1, x2, xn are IID random variables. So what is the condition for being ID? First of all, they are independent, correct? And second one is, what do you
Identical.
mean by identical? Identical means their marginal PMS of each
If we say
xi are identical, right? So far, so good. Did you get the idea?
Yes, sir.
Marginal PMF of each FXI are identical. Okay. Now, so let's say, so have you seen that geometric distribution, right? Okay, let's some example. Let's say I'm going to toss a coin some multiple times. Okay, is this IIT?
yes, sir.
Yes, sir.
Yes, sir.
Now,
Yes.
suppose you are going to toss a coin, let's say two times, twice. Then outcome of the first trial will be independent to the outcome of the second trial,
Yes.
Yes, sir.
correct?
Yes.
And
Yes.
marginal PMF for first will be same as the marginal of the second,
Yes, sir.
Correct.
correct?
Yes.
The same you can create the scenario of throwing a die, something like that. Okay.
Yes, sir.
Okay. So is this the idea is clear so far?
Yes, sir. Yes, sir.
Okay. So I think many of you. Okay. How many of you are clear with the geometric distribution, or is this any doubt for that?
No, sir, it's clear.
Clear for all or any?
Sir, please explain if you have time.
Okay. Okay, fine. So let me explain the geometric distribution because this is the something which is important kind of thing. So see, there are scenario. So okay, in binomial distribution, okay, how will you identify the binomial distribution? Or is the, or suppose there is a trial, you identify this is the binomial. So for, there will be something you will be performing some independent trials, right? Some IID Bernoulli trials, right?
Yes, sir.
And there for each trial there will be success failure, right? Okay.
Yes.
What if there is a case you are interested to know how many trials or how many attempts it will take or my random variable will take to get the first success. Okay, for example, you are going to toss a coin, let's say 10 times, for example, okay, and I'm interested to know the number of trials. Be clear with the statement, number of trials, okay, required to get the first success. Okay, that's a success you are defining to get the first head. Okay, so for example, okay, for example, suppose you got the first head at, let's say, some ninth trial. Okay, that means what? Till eighth you got tail, right? Something? Yes or no?
Yes.
Okay, till eighth trial you got tail, and for suppose to get the head success probability is p. That means for till eighth it will be 1 minus p.
Yes.
So it will be 1 minus p into 1 minus p up to 1 minus p, and at the ninth trial you got p, for example. Okay, basically here number of trials will not be fixed. Okay, initially I told 10 trials. Here it will not be fixed number of trials. Suppose you are just tossing a coin, and you got the first hit at the ninth trial. Okay, so this will be the probability, correct?
Yes, sir.
That means 1 minus p raised to power 8 into p,
Yes.
correct?
Right.
So in general, we will say, suppose I'm saying x is following geometric distribution with probability, success probability p, then my random variable x will take value k the probability, I mean, the PMF will be 1 minus P raised power. So this means I'm getting the success at kth trial. Okay. So if you are getting the success at kth trial, that means you got the failure till k minus 1
P
trial,
minus 1
and
times.
till
Yes,
k
got it now.
at the kth trial you got the success. Okay.
Yes, sir. Now
And
got it.
this a will be 1, 2, and so on. So why 1?
Yes,
Because we
It
are
starts
interested in number of
with the first trial.
attempts, number of trials. So it will take value 1, 2, 3, and so on. Is this clear?
Yes, sir.
Yes, sir.
Okay.
Yes.
Now, so I think there is one example in the lecture itself, if I'm not wrong. So I think let me open that. Just to give me a minute. So should I? Okay, let me open the activity question itself. Okay, so let's discuss. That will be fine. What about question number 2 and 3? Let's discuss. It will be clear to all of you. Will that be all right?
I have doubts on
Yes,
question
sir.
number
Sir, I
3.
have doubt in
I
question
do
number
have.
2, sir.
Question number 2 for everyone. Okay, good. That will be fine.
I have in 3, sir.
No problem. Okay, we'll do both 2 and 3. Okay,
Okay,
no
sir.
problem. Okay, yeah. So let's see this question number 2. I think first one is clear. This is just a statement and all, right?
Yes, sir.
You can cross it.
Yes,
So
yes.
what question number 2 says? X1, X2, X10 are IID geometrics. You know IID, right? It's all are independent identically. So identically means this marginal PMF should be same. Okay. For example, let me. Sorry. 1 second. Suppose this is axis taking value 0 and 1, 0 and 1. For example, this is 1 by 4, 1 by 4. This is 1 by 4, this is 1 by 4. Okay. So you can check whether these all are independent and marginals are same or not. If you see marginal are half, 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 and half, correct? And whether this is the same or not. If you see join this, so 1 by 4 equal to 1 by 2 into 1 by 2. Correct? I think it's the IID, right? Yes? Yes or no?
Yes, sir.
Yes,
Are
sir.
you getting? Marginal means fx of 0. This is same as fy of 0, which is 1 by half. Sorry, 1 by 2. Correct?
Yes, sir.
Okay. Yeah. So this is the meaning of IID means marginal should be identical, should be same, and that. Now, question number 2 says x1 up to x10 are IID geometric 1 by 5. So x1, x2 up to x10. This is IID geometric 1 by 5. If this is geometric 1 by 5, that means P is what? 1 by 5?
Yes.
Correct?
Yes.
Yes, sir.
Now, we have to find the probability that x1 greater than 10, x2 greater than up to x10 greater. So it's a simple, right? What's the doubt? No problem. Let me discuss. x1 greater than 10, x2 greater than 10 up to x10 greater than 10, right? This is the something, right? Now tell me, this is IID, so this should be independent, right? If two
Yes.
random variables are independent, then I will say x1 intersection x2 should be probability of x1 into probability of x2. Yes or no?
Yes,
Yes,
sir.
sir.
Intersection means comma, joint, right? Correct? Now,
Yes.
if there are 10 random variables, so I can simply say, since we know in the information say IID, by using the independence concept, I can say x1 greater than 10 into probability of x2 greater than 10 up to probability of x10 greater than 10. Yes or no?
Yes, sir.
Yes.
Is this clear so far?
Yes, sir.
Yes,
Now,
sir.
Yes,
tell
sir.
me if all are IID, then all the probabilities should be same.
Yes, sir.
Yes,
Yes.
sir. Should
So
be
I
so.
can simply say probability of x greater than 10 into probability of x greater than 10. All the probabilities should be same or not? Because all are IID, right?
Yes.
I can simply say probability of x greater than 10 raised power 10. So far, so good.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes or no? Right?
Yes.
Now, what do you mean by probability of x greater than 10?
1 minus p.
X 1 minus
P.
6
1
and
minus p raised to n.
Basically, I think there is
Sum of
one concept. I
1
mean,
minus p raised to the power 10, sir.
n, right? Basically, I
Yes.
Yes.
think that I forgot to discuss. I think I directly jumped to question. So that I will discuss in a minute. So if probability x greater than n, it's came from the then okay. Then it's same as 1 minus p raised power n. Okay. So
Yes.
it will be 1 minus p, and p is 1 by 5 raised power
10.
10, right? And which is already in this 10, right? Yes or no?
Yes, sir.
Correct. So
Yes.
it will be 1 minus 0.2 raised power 100, right? I think, is there any option? Yeah.
Yes, sir. Second one.
So could you go
So
back
the
to the
last line, can you
problem
repeat
once?
it again?
So this is the correct one. Actually, if x is geometric distribution, right? Then probability of x greater than n is same as 1 minus p raised power n. Okay. So if probability x greater than 10, it will be 1 minus p, and p was 1 by 5 raised power 10, and this 10 already it was already in the power. Clear?
Okay.
Is this
Okay.
clear now?
Sir,
Yeah.
Yes. So
yes, sir.
actually, we are considering n power n, right? So that's why the confusion is. So
Yeah,
it's
it's 100,
similar
right?
to j power n, right?
Correct. Is this clear?
sir, if probability of x is less than n, then it should be p
1
raised to
minus.
n.
No, no, no. It's not for p raised to 1. Actually, see. Yeah,
Less than n.
less than n, then it will be 1 minus c. If probability x less or equal to n is some value plus probability x greater than n, it should be 1,
Okay.
right? So
Yes.
I will say, I'm saying probability x greater than is 1 minus p raised power n, right? Then
Right.
probability of x less than equal to 1 will be 1 minus this thing. Basically, it's nothing but we are using probability of a complement equal to 1 minus probability of a. This concept. Okay.
But 1 minus.
Yeah, I will
It's
see. If
then.
you have doubt how this come, I will derive. Okay. And this is something, it's a concept of complement.
Yes, yes. That
Okay.
I got it.
Okay. Yeah. So question number 2 is okay, fine. Someone had doubt from question number 3 as well, right?
Sir.
Okay. So question
Yes, sir.
number 3 says a random experiment consists of rolling a fair die until 6 appears. Okay. Just read the question carefully. It's a random experiment consists of rolling a die until 6 appears. Means here 6 your, if 6 is there, that means your that will be your
Geometric.
first success. Correct? Okay. Means I'm tossing a coin until get. I mean, then I will get the first head, right? Okay. That success can be anything. Whether you are interested to get the 6, whether you are interested to get the 2, it can be anything. But here it's 6, right? X denote the number of times the die is rolled. Suppose 6 doesn't appear until the 6th throw, right? Find the probability that 6th will appear after the 8th throw of die. What do you mean?
Again, n is equal to
Probability of
0
x
from
greater
7.
than
I
8.
mean from 6.
See, it says 6 will appear after the 8th throw. That means, can I say probability of x greater than 2?
Yes.
Okay. I think I should explain memory less property before that. Okay, let me explain. That will give you idea. Okay, there is one concept in case of geometric distribution called the memory less property. Okay, so what is the memory less property? It's nothing but if probability x greater than some m plus n. Okay, given that x is greater than n. Okay, it will be same as probability that x greater than n. Okay.
Yes, sir.
I mean, so it suppose I'm saying any. I mean, there is. I mean, this random. See, my random variable x has the memory less property. I mean, here, if this is the case, I will say my random variable x has the memory less property, basically. Okay. So what does this mean actually? So if I will say this x is, suppose I'm saying it's a given that x is greater than m. Okay. It's a given that, right? If you see in this question, 6 doesn't appear until 6 through. Okay. It simply say x is failed till m, right? Yes or no? Are you getting? It will occur x greater than m means 6 plus 1 after 7th trial means it's greater than 6. This is given. Are you getting? Now,
Yes.
the probability that 6 will appear after the 8th row. That means this x will appear 8th row means 2 plus 6.
Yes.
Right? So this will be same as probability x greater than 2. That is the something that question is trying to say actually. Okay. So
Sir,
should I do? Yeah.
why it called memoryless property?
Basically, it's you can simply say it's constantly forget about this case. About this case, whether it will forget whether it doesn't happen till m. It will continue. It will count from n onwards. More after n1 onwards.
Sir, can you explain why it's probability x greater than 2?
Okay, just try to apply these things.
Sorry, it would be x is equal to 2, right? If I'm not wrong.
No, x greater than 2. See, if it clearly says, suppose 6 doesn't appear until the 6th row. That means it will appear after 6, right? It similarly say, I mean, it simply says x greater than 6, right? See, x following geometric p, that means, if I will say probability x greater, x equal to k, that means I'm going to get the success at kth trial. In that question, it says it doesn't get 6 till 6th row. That means it's given that it will get the 6 after 6th row, right?
Yeah, but the last part of the question also says that find the
Probability
probability.
6 will 6 appear after the 8th row. After the 8th row means
yeah,
more than
got
8,
it.
right?
Got it. Yeah.
Right. So it should be 6 plus 2, right? Correct?
Yes, exactly.
So it will forget about previous 6 throw. So it will simply say x greater than 2. Is this clear?
Thank you.
Right?
Yes, sir.
Should I do the derivation or you are okay with the derivation? If you are okay, then I can move forward.
Sir, got it now. Thank you.
If it says find the probability at 8, so at that point of time x equal to 2, right?
Yeah, that point it will be at 8, right? Accordingly, this statement will also change. Okay.
Yeah.
Fine.
Okay,
So now you got right. So now x greater than 2, probability x greater than 2, we discussed just few minutes. If x is greater than n, it will be 1 minus p raised power n, right? So x greater than 2 means 1 minus, and p was 1 by 5 raised power n. So it
5
will
by
be
6.
4 by 5 raised power. 1 second. It's not
1
n.
by 6, it's 1 by
Sorry,
6.
it's die. Yeah, sorry.
1 by 6, sir.
Yeah, sorry. I took the probability of the previous question. Sorry about that. So it will be 1 by 6. Okay. It will be 1 by 6 and power 2. It will be 5 by 6 raised power 2. So option number B is the correct. Okay. So anyone, do you want this derivation or should I move if it's okay from the lecture or
Please.
anyone?
Sir,
Yeah.
sir, in the
Derive.
previous question, if our random variables were given x greater than 10, if the question was random variables are x greater than or equal to 1, oh sorry, 10, then in the second question that you have done it previously,
You're talking x greater than 10.
equal to x greater than or equal to 10.
See,
So
accordingly,
there
these things we have to satisfy actually.
then
Okay.
Earlier you used the
She asked me about the before
See,
question.
memory-less property. I got your point. You are talking about equality sign, right?
yes,
So since
even
this
in
is
the
a
previous
discrete case,
question as well
yeah.
as in this question.
Okay. So, okay, you're talking about this x greater or equal to 10, this case only, rather than x greater than, right?
Yes, yes. If we get something like that,
Hmm.
how we will use this geometric?
You can simply you can simply apply the summation sign.
Okay, for equal to 10 and
Ha.
just
Yeah.
take the union
Because
for
see,
x greater than 10.
see, you can do one thing. See, if x is greater or equal to 10, right? So you can simply write probability. What you can write x something greater than 9
Yes.
plus. You can split, right?
11. X greater than 11 and then
Ah,
x.
sorry. X equal to 10,
Yes.
right? Yeah. Then
Thank you. I got it. I got
got
it.
it. Yeah. Okay. So let me do let me derive that memoryless property. Okay, and then we'll
And one
move.
more thing is this memoryless property is only that you are discussing is for geometric distribution.
Geometric distribution as well as its exponential distribution. Since exponential is continuous, so we will discuss in the when we will move to the continuous case. Okay.
Okay.
Yeah.
Thank you.
Yeah. So memoryless property says probability that x greater than m plus n, given that x greater than n, it will be same as probability x greater than n. Okay. Now, so let me derive. So probability x greater than n means what? We know I have to add. See, we have to add PMF, right? So here k will be n plus 1 up to infinity. Yes or no? Are you getting the idea? See, x greater than n means what? We have to add the probability x equal to n plus 1 plus x equal to n plus 2 plus so on.
Yes, sir.
Right?
Yes.
So this is the same case I have written, right? Now,
Yes.
from here, if you see p, I can take outside, right? And summation will be k equal to n plus 1 raised power infinity 1 minus p raised power k minus 1. Yes or no?
Yes, sir.
Now, if you apply the summation sign, what it will be? 1 minus p raised power n, because it will be n plus 1 minus 1, right? It will be 1 plus 1 minus 1. We have to replace the value of k, correct? Plus 1 minus
Sir.
p power n plus 2 minus 1 plus 1 minus p raised power n plus 3 minus 1 and so on.
Yes, sir.
It will be p and this one will get cancelled out. So it will basically 1 minus p raised power n. Then this 2 minus 1, it will be 1 minus p raised power n plus 1 plus 1 minus p raised power n plus 2 plus so on.
Yes, sir.
Yes or no? So I can take 1 minus p raised power n as a common. Then I will be having 1 plus 1 minus p plus 1 minus p square plus so on.
Yes, sir.
Correct? So
Yes,
what
sir.
is it? This is the GP, right? Correct? So if it's GP, so it will be 1 upon 1 minus R, right? You know this case 1 plus R square and so on. If R is less than 1, then summation of this series will be 1 upon 1 minus R, right? So instead of
Yes,
R,
sir.
I have 1 minus P, right? Correct?
Yes.
Yes.
So it will be P into 1 minus P raised to power n divided by 1 minus 1 plus P. 1 will get cancelled or this P will get cancelled with this. So I got probability x greater than n as 1 minus P raised to power n. Is this clear? The same thing we had used in the previous, right?
Yes, sir.
Now, for the
Sir.
memory list property, we know probability x greater than m plus n, given that x greater than m. So we have to prove it's the same as probability x greater than. Now, by using the condition of probability, can I say probability x greater than m plus n, comma x greater than m, right? Intersection part, divide by probability
Yes.
of x greater than m. Any doubt?
No, sir.
What's the common part for the numerator part?
M plus answer.
Right? So it's basically same thing is suppose and this is the m, this is the m plus n, right? So I'm saying greater than m. So that means this green region, right?
Yes, sir.
Now again I'm saying m greater than m plus n. That means this blue region. So
Yes.
what is the common?
M
Blue
plus
region,
n,
right?
greater than m plus n.
Greater than m plus n.
N region.
So it will be probability of x greater than m plus n divided by probability of x greater than m. And by using this case, in the numerator part, I will be having 1 minus p raised to m plus n. divide by 1 minus p raised to power n. Yes or no?
Yes, sir.
Correct, by using this part, this star, right? So if you see, this will get cancelled out with this, and I will be having 1 minus p raised to power n, and which is same as probability that x greater than n. Okay, so this is the proof of your memoryless property. Okay, is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Okay, no problem. So I think let's move to the next part of the like concept, which is I think a function of one random variable, right? If I'm not wrong. Yes or
Yes,
not?
sir. Yes,
Yes,
sir.
sir.
Okay. So let's move to the function of one random variable. What do you mean by the function of that one random variable? Okay. For example, let's say I see
Sorry,
one.
sir. Sorry for interrupting, sir.
Hmm?
I have a doubt in the previous topic
Hmm?
from activity question, sir.
Which activity question?
2.4, sir.
2.4. Till now, I haven't discussed the function of random variable.
Question number last, sir. Fourth one.
So this is the function of that random variable. I will come to that point. Can you see? This is the topic about function of random variable.
Okay.
I
Okay, sir.
am going to just start what is the function of random variable. Okay.
Okay, sir.
Yeah.
No problem.
Okay, fine. So I'm going to take one example from the lecture video itself. Okay. What's the function of one random variable and all? Okay. So let's say we can take this one, any problem, this y minus 5, or let me take some another also. Okay, no problem. Now, suppose I'm saying x is discrete uniform, okay, for example, and it's going to take value, let's say minus 1, 0, 1, for example. Okay. Now I'm saying I am going to define a function of this random variable y as a x square. Okay. Now question is, what is the distribution of y? So this is the question part. Okay, tell me, how will you proceed? See, to know the distribution of y means, what is the PMF of probability mass function? If it's discrete random, what's the PMF of y? To know the PMF, first of all, I have to find the range of y. Yes or no?
Yes.
Then I have
Yes,
to
sir.
find the what is the probability the random variable. What will be the probability for each value of y? Okay, now. So it's a good. X is taking value. What are the value? Minus 1, 0, 1. Right? And what is the probability when X is taking value?
1 by 3.
1 by 3, because it's a discrete uniform, right?
Yes, sir.
Yes.
Now, why I have defined as the x square, right? So what is the x square? So my value of minus 1 square will be
1.
1,
0 square is
0.
0,
1 square is
1.
1. Now, what is the probability for this case? For 1, it's 1 by 3.
Yes.
yeah,
It's a 0 for 1 by 3. Then again 1 by 3, right? But if you
Yes.
see carefully, my y is taking only two values, 0 and 1, right?
Yes, sir.
And what is the probabilities? For 0, it's 1 by 3, correct? But for 1, it's a 2 case, right? This
Yes.
1 by 3, this 1 by 3.
1 by 3.
So for this probability y equal to 1, you can simply say for y equal to 1, there is 2 case, right? Whether x will be minus 1 or x will be 1, right? So I have to add both probability 1 by 3, 1 by 3, it will be 2 by 3,
3.
right? Is this clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
This is something you can, so it can be x square. Instead of x square, suppose it's x minus 1 square, right? So instead of x square, you have to do 1 minus, x minus 1 whole square, right? Something like that. So function of one random variable is all right. Is I think it's the simplest one, right?
Yes, sir.
Correct. You will be able to do the right.
Yes, sir.
Okay. Then let's move to the function of two random variables. Okay, that is something. Now, let's say I'm saying I have two random variables x and y, both are IID. and these both are IIT uniform. I'm just taking two values for our simplicity as of now. Now, function of two random, suppose I'm going to define G as a x plus y. Now, we have to find the distribution of Z. Okay. To find the distribution of Z, first of all, I have to find the possible values x, my random variable Z will take, right?
Yes, sir.
Yes, sir.
Now tell me, before this case, before finding the calculating the probability and all, uh, they see whenever you will get the function of two random variables, right? So it's a general suggestion or general approach. See, you can do the directly. What is the possible values my random variable Z will take, but it's good to write down all the possible cases. So what's the advantage of that? I mean, there is very less chance to make the mistakes because see, sometimes what happens, see, for example, you forgot to add this case, right? Because for one, there will be some case, right? Suppose there is some large number of values. Then suppose one is coming three times, and you simply, I mean, you are doing the calculation in your mind, and you got just 2/3. But in reality, suppose it's for three cases, right? Then you have to add the probability for three times, right? So it's good to add all the probabilities. So what are the possible cases? So possible cases will be x will take value 0, right? Y will take 0, right? X can take 0, Y can take 1. X can take 1, Y can take 0, X can take, Y can take 1. I mean, these are the possible four cases, yes or no?
Yes, sir.
Yes, sir.
Right? Now, what is the probability for these two? Since this is the IIT, so see, half for each, right? Okay.
Yes, sir.
So half for this, half for this, it will be 1/4. Yes or no?
Yes,
Same,
sir.
half for this, half for this, it will be 1/4. Then 1/4, then 1/4.
Yes.
Now Z, we have to calculate for Z. So x plus y means what? So for the very first case, so 0 plus 0, Z will take 0, correct?
Yes.
Then 0 plus 1, it will take value
1.
1. 1 plus 0, 1.
0.
1 plus 1, 2, right?
2.
So if you see, at the end, my Z will random variable Z will take value 0, 1, and 2.
1, 2.
What is the probability for 0? It's a
1/4.
for
1 by
1.
4.
We have to
Half.
add 1 by
1 by
4
2.
plus 1/4
Yeah.
because this is the
Yes.
one is taking for two cases, right? So it will be
Yes,
2/4,
1 by
which is half. For 2, it's a 1/4.
1 by
So
4.
probability of Z equal to G, it will be 1/4, 1/2, 1 by.
4.
Right? Is this clear?
Yes.
Yes,
Are you
sir.
getting the idea, right, for this case?
Yes, sir.
Okay. Now, let's move to the see function of random variable. So, maximum of maximum of two. It's also function of that random variable. Right? It will comes under that one. Yes or no?
Yes, sir.
Right? Just a minute.
Sir,
Yeah.
in the both the cases, that distribution is not a uniform distribution, right?
That's a uniform distribution.
Means this,
I took XY as a IIT uniform. Okay.
yeah. But what is the distribution of Z?
Yeah, distribution of Z is not uniform because
Yeah.
probabilities are different.
Yes, yes.
Okay. Uniform is it will take it should take
Equally.
probability, yeah, it's equally likely basically.
Yeah, equally likely.
Yeah, it's should be equally likely. Okay. Okay, now let's come to the part of maximum of two random variables. Okay. Now similarly, if it's x plus y, similarly you can find the value for x minus y and all. Yes or no? Is this all right, right, for everyone?
Yes, sir.
Yes.
Yes, sir.
Yes.
Okay, fine. Yeah, sorry. Yeah. So let's move to the maximum of two random variables. Okay. Okay. So far, so good. Any doubt?
No, sir.
Sir, is that example one to one or is it many to one, sir? The previous one, function of one random variable.
It's I think only, right? It was for two random variables actually.
Okay.
Basically. Okay.
Anything.
No. So in case of like this function of random variables, right? So simply it can be say x plus y, it can be x into y, it can be let's say x two times of x plus y, right? In any kind of things I can define, right? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
So let's before going to that maximum, let me define that I mean addition of two random variables in general for our simplicity. So addition of I mean sum of two random variables. Okay, in general. So sum of two random variables. Okay. Now, what is how I can define? Suppose I have x and y. So there is we are going to consider when these are this random variable are taking only integer value. Okay. So, I mean, this is the we are generalizing in case of integer value. Suppose x and y both are discrete random variable which are taking integer values, okay, only, and joint PMF is some suppose fxy. Okay, I can define fx joint PMF. Now, suppose I'm going to define z as a x plus y. I mean, function of these two random variables. Then, how I will find the probability of z equal to z? Now, see, if you see in this example, how did you find? Okay, I added values for x and y, right? Each possible case, correct? Basically, it will be probability x plus y equal to z. So this z considered as a small z, right? Now, so to know the this case, what I can do, either I can add for let's say I'm saying I can add, see, if suppose I'm saying x equal to x, then this will case will be true when then y will be z minus x, right? Only then x plus
Yes,
y
sir.
will be x, right? Yes or no? Sorry, z. Are you getting?
Yes.
Everyone is getting this case? So
Yes, sir.
basically, I have to add all this case for the possible values of x. If I'm converting in terms in form the of x, right? What is this? This is the simply I can say x is taking minus infinity to minus plus infinity means all the possible values of x. So basically I can say joint PMF of x y when x comma and y is taking z minus x. Is this clear? Right? The same case I can do for y. So if you talk about y, then it will be fx y of, if I'm talking about in terms of y, then it will be, see, for y it will be y, then it will be z minus y,
Z minus I.
right? Only then summation will be the same, right? Okay, is this clear?
Yes, sir.
Okay, the same procedure is there. We can apply the case. Okay, I think after this we have addition of two Poisson random variables, right? And the one of the conditional distribution of x given z, that I mean when it comes to binomial distribution. How many of you covered till lecture 2.10 to 2.11? I will be having some idea whether I should derive the things or it's will it be okay for everyone?
I haven't covered, sir.
Okay. Can you raise
No,
hands those who have not covered? Okay. Some 2, 3, 5, 6, 8, 11. Okay. Okay. Got the idea. Okay. So meanwhile, just can you tell me so far it's clear to all of you?
Yes, sir.
Okay. You got the idea function of random variables, independence, IID, geometric, and all right. Memory less, everything.
Yes, sir.
Correct. Okay.
Hello,
Then there
sir.
is yeah.
Sorry, sir, but I have matlab, where I found the weekly timed assessment for Python. I'm not found in the course.
Okay, so Vivek, can you ask to the Python instructors? They will help you out.
Sir, today is the last date for submit. I didn't found that where it is. So anyone knows the can we tell?
Yeah,
When
please. If any one of you knows are aware about this thing, just help to Vivek Kumar. Okay.
Just refresh the page.
You can refresh.
Yeah, it will appear after some time.
after sometimes it will appear.
Yeah,
No,
yeah.
when you refresh it, you
Okay.
Okay,
Sir.
Vivek, just try this out. Okay.
Okay, sir.
Fine. Okay, so in I think in lecture 2.10, if I'm not wrong, there is two concept addition of two Poisson random variables and conditional distribution of one. I mean addition of two Poisson and then one Poisson. I will tell you what's the case. So those that thing is a little bit important. Okay. Now, so I mean we will be using this concept actually. Okay. Now, so topic is sum of two independent Poisson random variables, right? Poisson. Now, so case is suppose so I will be interested to know. Let I'm saying X is following Poisson distribution with parameter, let's say lambda 1, and Y is another random variable which is following Poisson distribution with parameter lambda 2. Okay, and these two are independent. Okay, I'm taking these two are independent. Then we will be finding first case PMF of Z equal to X plus Y. Okay, and second case we will find the conditional distribution of X given Z. So this X and this Z. Okay, so we will be calculating these two. Now, if you see this Fz case, okay, then addition of two random variables Fz of Z, okay, it's the same as X equal to, okay, so it will be Fx of X into Fy of Z minus X, or let me write down in case of like this. So it will be probability X equal to X into probability that Y will take Z minus X, yeah, or not. I mean this case, right? The same
Yes,
case
sir, it
I
will.
have used, right? This one.
Yes.
Are you getting what I'm trying to say?
Yes, sir.
Okay. And what is the possible values my random variable X will take here? Tell me. Okay. Suppose I'm saying X is following Poisson random variable. Then what is the possible values X will take? Tell me in terms of Poisson.
E bar minus lambda into.
That's the PMF. I'm talking about range.
0 to infinity.
0 to infinity, right? So here, what is the possible values X will take? X will take 0 to Z or not? Would you agree with me?
Yes, sir.
Yes, sir. Yes, sir.
It will.
Or I can go with the 0 to infinity also, no problem. Sorry. Okay. So basically that's the range. Now tell me what is the PMF for this? So it should be e raised power minus lambda, right? So instead of lambda I have minus lambda 1, right? Lambda 1 is for X divided by
X factorial.
right? Now what about this? E raised power minus
Minus Z minus
lambda 2, right? Lambda 2 raised power Z minus
Z minus X.
divided by
Z
minus
Z
X
minus
factorial.
X factorial.
correct?
Yes, sir.
Now, see, it's a basically it's a 0 to infinity, right? It will be 0 to infinity. Basically. So what is the range? X equal to 0 to infinity, right? Now, what are the things I can take outside of the summation? This e raised power minus lambda 1 and e raised power minus lambda 2. Yes or no?
Yes, sir.
So I can take e raised power minus lambda 1 minus lambda 2. I will be having summation of x equal to 0 to infinity. So lambda 1 raised power x and lambda 2 raised power Z minus X divided by X factorial into Z minus X factorial.
Yes.
So those who have not watched the lecture video, are you getting the idea?
Yes, sir.
Yes,
So
sir.
this is e raised power minus
Yes, sir.
lambda 1 plus lambda 2 minus I can take outside of the, right? It will be summation of x equal to 0 to infinity. So I can separate the terms, right? Lambda 1 raised power x. Yes or no? I mean, I'm talking about these things. Can I do these things?
Yes, sir.
Right? Without any problem, right?
Yes, sir.
So we'll see. Can you see these things? If let me do one thing. Now you will be having some idea. Summation of x equal to 0 to infinity. If you see carefully, I have x factorial divided by z minus x factorial, right? Lambda 1 raised power x, lambda 2 raised power z minus x. So if I will multiply with the z factorial and divide by z factorial, can I do this thing?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
It will be e raised power minus lambda 1 plus
Lambda 2
Lambda 2
divided by.
z factorial.
Now it will be x equal to 0 to. I will not write the upper limit. What about this?
and Z2 sec
Z z x, right?
Yes.
And lambda 1 raised power x, lambda 2 raised power z minus x.
Yes, sir.
Right? So now tell me what will the upper limit of x upper limit for x?
Z.
Right? It will be z, right? Because others probability will be 0 actually. You can write infinity, but it will be 0, right? Yes or no? Are you getting what I'm trying to say here?
Yes.
Okay. We know, so if I will add summation of x equal to 0 to n, right? For example, I have n choose x, right? And p raised power x, then q raised power n minus 1 x, then it will be q plus p raised power n, right? This is the binomial expansion. Yes or no? So from here, it will be e raised power minus lambda 1 plus lambda 2. Can you tell me the things? It will be z factorial. What about these things? Lambda 1 plus lambda 2 raised power n. N means this addition of these two, right? Yes or no?
Yes, sir.
So it will be x plus z minus x. So x will get cancelled out, right? So I will be having e raised power minus lambda 1 plus lambda 2 divided by z factorial into lambda 1 plus lambda 2 raised power z.
Yes, sir.
So what is this now?
Again, Poisson, sir.
Again Poisson distribution, but with the parameters lambda 1
Plus
plus.
lambda.
So can I say if x and I mean, let's say x is following Poisson distribution with parameter lambda 1 and y follows Poisson distribution with parameter lambda 2 and both are independent, then sum of these two will again be Poisson distribution with parameter lambda 1 plus lambda 2.
Yes.
Yes or no?
Yes, sir.
This is something I can identify, right?
Yeah.
Yes, sir.
Now, I have written one more thing. Be careful, it should be independent. We are interested to know the conditional distribution of x given z. Okay, so just focus a little bit more here. So suppose I'm interested to know the conditional distribution of x given z. Then and this z is nothing but x plus y. Now, so suppose I'm saying I'm interested to know probability x. Let's say I'm saying x is taking some value k. Given that z is taking some value n, I have to find the for our simplicity. We are going with this. Okay. Now I can apply the conditional concept here. I can simply say x equal to k in and z equal to n. Divide by probability of z equal to n. Any doubt?
No.
This thing I can do, right? Yes or
Yes.
no?
Yes.
Now, for the numerator things, can I apply the multiplication rule? Multiplication rule means I can simply say probability of x equal to k into probability of z equal to n given that x equal to k. Yes or no?
Yes, sir.
For the numerator case only.
They are independent now.
They are not independent. See, z is nothing. Z is x plus y. X and y are independent. I'm not saying x independent and x plus y will also be independent, right?
Ah, yes.
Are you getting the idea? Is okay?
Yes.
So numerator part I can write down like this. Okay.
Yes, sir.
Now, if probability of x equal to k is there into what is the z? Z simply I know x plus y equal to n, right? Given that x equal to k. Yes or no? And
Yes,
divide by
sir.
probability of z equal to n. Okay. Do let me know if at the any step you are not getting the point. Okay.
Sir, I'm not getting that logic.
Which one?
Yes.
Yes, sir.
Which
No, sir.
which
Sir, in previous step.
this one?
Yes, sir. Yes, sir.
Yes,
Okay.
sir. Yes.
By the multiplication rule, if I have A intersection B, can I write probability of B into probability of A given B?
Yes, sir.
The same thing
Yes,
I
sir.
have written here.
Oh.
Or simply you can apply the conditional probability also. Both are the same actually. This multiplication rule we got from the conditional probability formula, right?
Oh, okay, sir.
Okay.
Okay.
Now, if this is the case, if the numerator case for this, can you tell me probability x equal to k? What about this case? Now tell me. I want to split in terms of y. If I'm saying x equal to k, is given that x is taking value k, and what's the probability of x plus y equal to n? Then what will be y?
N minus
Correct?
plus 1.
So I can
Minus
simply say probability of y equal to n minus k.
n minus k or n minus x.
N minus k, right? X is taking k.
Oh, okay, sir. Okay, sir.
Okay. Divide by probability of j equal to n. Sorry, z equal to n. Yes or no?
Yes, sir.
We know now. We have information. This is the Poisson distribution with parameter lambda 1. This is the Poisson distribution with parameter lambda 2. This is the again Poisson distribution with parameter lambda 1 plus lambda 2, right?
Yes, sir.
Right. For the x equal to k, I can simply write e raised power minus lambda 1. Lambda 1 is for x. So instead of x, I have k. Divide by k factorial into e raised power minus lambda 2. Lambda 2 raised power, tell me,
N minus k.
n minus k. Divide by n minus k factorial. This is the numerator part. Divide by in the denominator, it will be e raised power minus lambda 1 plus lambda 2 into lambda 1 plus lambda 2 raised power what? N divided by n factorial. So far, so good.
How did you write, sir, p y is equal to n minus k instead of the whole previous term?
Okay, so what is the meaning here? I'm saying x plus y is equal to n. Okay.
Okay.
Basically, I'm saying x probability of x plus y is equal to 5. Now I'm saying x is 3. So that means what? Y is equal to 2.
Yes, sir.
Right? The same thing I have written. Is this clear?
Yes, sir. It's clear now.
No. So let's split the things. You just form a lambda 1. Okay. So lambda 1
But
is
sir, the probability of y is equals to 2 given x is equals to 3 as well, na? Conditional. Because x and y
See,
are
x,
independent, then there will be one more
one
component.
second. X was 3. That's why y is 2. See,
Yes,
I'm simply saying. See, I'm simply saying probability that x plus y will be taking value 5. Okay. For example, this is another case. Now, in the same case, I'm saying x plus y is 5. Now, I'm saying x is taking value 2. That means what? Probability of y should be 3, right?
Yes, sir.
Not given, right?
Probability of x from numerator and denominator get cancelled because x and y are independent.
Yeah.
Yes.
Yes,
Okay.
I got it, sir.
See, the same thing I was writing directly. Okay. Now, these things I can write down like this. Right. So n factorial I can take up numerator part, right? Is this? I mean, this mathematical things is clear, right? Or any doubt? Is this okay?
Yes, sir.
Okay.
Yes.
Now what we can do? Now you can see this e raised power minus lambda 1, and these things will get cancelled out with this term. Yes or no?
Yes,
right?
sir.
So I will be having here n factorial divided by k factorial into n minus k factorial into lambda 1 raised power k into lambda 2 raised power n minus k divided by lambda 1 plus lambda 2 raised power n, right?
Yes, sir.
Now, there is one small calculation. So that will give you one idea. So lambda 1 raised power k, lambda 2 raised power n minus k, right? In the denominator part, in the power, can I write k plus n minus k?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes,
I
sir.
can write, right?
Yes, sir. Yes,
If
sir.
this is the case, so I can simply write down n factorial divided by k factorial into n minus k factorial. It will be lambda 1 raised power k into lambda 2 raised power n minus k. In the denominator part, I can simply say lambda 1 plus lambda 2 raised power k into lambda 1 plus lambda 2 raised power n minus k. Yes or no?
Yes.
Correct? Now, if this is the case, it will be n factorial divided by k factorial into n minus k factorial. So simply I can say lambda 1 divided by lambda 1 plus lambda 2 raised power k, because power are the same. Then lambda 2 divided by lambda 1 plus lambda 2 power n minus k. Yes or no?
Yes, sir.
What is this? This is n choose k. Then lambda 1 divided by lambda 1 plus lambda 2 raised power k, and lambda 2 divided by lambda 1 plus lambda 2 raised power n minus k. What is this? Anyone can recall?
Binomial.
This is the
Binomial
binomial, because this is the 1 minus lambda 1 divided by lambda 1 plus lambda 2. Yes or no?
Yes,
Yes,
yes.
sir.
This part, right? If you write lambda plus lambda 2, lambda 1 will cancel out. So simply we got x given z is binomial with parameter n, and what is the success probability? Lambda 1 divided by lambda 1 plus
Lambda 2.
correct. So if you do, see, this is all for x given z. What about similarly, I can simply find out for y given z. So it will be binomial. Tell me now. N comma, what will the success probability?
Lambda 2.
Lambda 2
Divided by.
Lambda 2.
Now, is this clear?
Yes, sir.
Any doubt? Is this okay for everyone?
Yes, sir.
Yes, sir.
Okay, fine. So, so you can keep in your mind these things, like if you have two independent Poisson random variables. Give me a minute. So yeah, I was at the point, if we have two independent Poisson random variable, right? Then addition of the, I mean, sum of two independent Poisson random variables will be again Poisson random variables with parameters lambda 1 plus lambda 2, and conditional distribution of x given z will be binomial with a number of trials, comma, lambda 1 divided by lambda 1 plus lambda 2, and y given z will be binomial n comma lambda 2 divided by lambda 1 plus lambda 2, right? Now, so I think next concept is maximum and minimum of two random variables, right?
Yes.
Right. Now we have to suppose, so far we have discussed some summation of random variable. We can similarly find the the, x minus 5 2x plus 1, something like that, x minus 5 whole square, something like that. Now what about minimum and maximum of two random variables, right? Suppose I have two discrete random variables x and y, and with joint PMF these things. Okay, let's say taking value t1 t2 or small x small y, whatever. Okay, now, what about, and suppose I'm defining z as a minimum of two random variables x comma y. Now, how will I proceed? Okay, what is the distribution of fj? Okay, so fz of z, that means probability capital Z will take value small z. Okay, when, so this means probability that this z is what? Minimum value of x comma y equal to z, right? Basically this is the one of the value of this random capital, I mean capital Z, which is the random value variable, right? Is this clear so far?
Yes, sir.
This step is okay.
Yes, sir.
Now, so if the minimum case is there, so what will be the possible cases we have to identify? When will be the minimum of these two? Now, can I say minimum will be when x equal to g, sorry, x will take z and y will take z. Yes or no?
Yes, sir.
Right? Or x will take
Equal to
value
Z.
z and y will take more than z,
Yes, sir.
or x will take more than z and y will take only z.
Yes, sir.
Are you getting? Suppose I'm saying, see, tell me minimum of 2 comma 3 is 2, right? For example, this will be 2, right? Yes or no?
Yes,
When
sir.
you will
Yes,
get
sir.
this 2, when I'm saying minimum of 2 comma 2 is 2,
Yes.
right? Minimum
Yes.
of 2 comma 3 is 2.
Yes.
Yes.
Minimum of 3 comma 2 is 2. These are the
Yes.
possible cases only, right? The same thing I have written. Both will take value same, right? X will take value same and Y will be more than that, right? And then X will take more than Z and Y will take this. Is this clear? From where we got these possible cases,
Yes, sir.
right? Now, to find the minimum things, I have to add, since it's all are disjoint, then I have to add the cases. It means probability X will take value Z, Y will take Z, plus probability X will take value Z, Y is greater than Z, plus probability X greater than Z, Y equal to Z. Is this clear so far?
Yes, sir.
Now, how will you find these things? So this is nothing but joint of this Z comma Z, plus to find this probability. That means what? We have to add, let's say Y is taking value T2. So T2 should be greater than Z, right? And then fxy of Z comma T2, yes or no? We have to add all the cases, right?
Yes, sir.
The same for this case. We have to add all the cases when T1 is greater than Z, and then joint PMF of fxy T1 comma Z. Is this clear?
Yes, sir.
Right? Any doubt? Anybody? Yes, no? Is this clear, right?
Yes, sir.
Yes, sir. Clear.
Fine. So next, let's say I'm saying second case. Z is defined as maximum of x comma y. Then how will you proceed? I mean, what is the PMF for this? So fz of z. So this is nothing but probability of z equal to z. Now you people will tell me by using the minimum case. So it will be maximum of x comma y will be z. Now tell me what are the possible cases for that? When maximum of those two will take value z.
P of x is equal to
Probability of
z.
y equals Z.
So very first case will be when both are taking value z, right?
Yes.
Yes.
Or x will
Probability
take
of
z
Z and
less
y
than
is
z,
less than
less than Z.
correct? Or x is less than z, y equal to z, right? By the same case, you can say, suppose I'm saying maximum of 2 comma 3 is 3, right? So when this will be true, when both are same, then maximum will be 3, correct? One is less than, then maximum will be 3, and another one is less than, then maximum will be 3, right? So we can add all the probability, right? X equal to z, y equal to z, plus probability x equal to z, y is less than z, plus probability x less than z, y equal to, right? Now, this is nothing but joint PMF of these two when value will take z and z, right? Since there is a one case, so why we have to add all the probability. Let's say suppose I'm saying y is less than 2, right? So we have to all the cases before 2. That means we have to add summation T2 for z, so it will be less than z, okay? Then joint PMF of z comma T2, right? Same here, we have to add all the case values for x1 less than z, then it will be joint PMF of T1 comma z. Any doubt?
No, sir.
Clear, right?
No, sir.
No. So there is something minimum and maximum of independent, or you can say IID random variables. Why that is important? Because you will be finding some questions related to that, and I mean that is something important kind of things. Okay. Now let's see. You will be basically will tell me the cases. So suppose I'm saying let's talk about in general. Okay, before going to general, let's talk about for two random variables. Let's talk about x and y itself. Suppose I'm saying x and y, right? These are some IID with x. X means let's say x1 and x2, for example. X means this is following some distribution we don't know, but that is the IID. It can be geometric, it can be uniform, it can be anything, but x is something general. So I'm saying I have defined the z equal to as maximum of x1 comma x2. Okay. Now, suppose question is I asked what is the probability that this z will less or equal to z. I mean basically CDF of this random variable z. Now, so there is one approach which is very simple. So to write down probability z less or equal to z, what I can write down? Maximum of x1 comma x2 less or equal to z. Yes or no? Right? Any doubt?
No, sir. Please repeat it again.
Sorry?
Repeat it once again, sir.
Okay, so question is suppose I'm saying x1, x2 are two IID random variables, right? With from distribution x. So this distribution x means it can be anything. I'm talking about in general. It can be geometric, can be uniform, it can be anything, right? So I have defined one z random variable z, which is the maximum of x1 comma x2. I mean initially I took x comma y. Now we are just changing the form. Now we are taking about maximum of x1 comma x2, right? Question is what is the CDF of z? Okay. There is question what is the probability z less or equal to z? That means probability maximum of x1 comma x2 less or equal to z, because this z is defined as maximum of x1 comma x2. Yes or no?
Yes, sir.
Got it.
Now, if maximum of something is less or equal to some value, suppose I'm saying, okay, you will tell me if maximum of 2 comma 3 is less or equal to 2, that means what? I can simply say 2 is less or equal to 2, sorry, less or equal to 3. I can simply say 2 is less or equal to 3 and 3 is less or equal to 3.
Yes, sir.
Because maximum is 3, right? So I can simply say 2 is less or equal to 3 and 3 is less or equal to 3. Yes or no? So now can I split from here? I can simply say x1 is less or equal to j and x2 is less or equal to j or not? Tell me.
Yes, sir.
Is this clear?
Yes, sir.
Now, since I'm saying it's a IID, so before IID is independent. So if it's independent, so it will be equal to product of their marginals case, right?
Sir, x1 less than equal to z1, or it is z comma? Okay,
It's a comma. It's a comma. See, it's a and basically. See, I'm saying maximum of first of all. Suppose I'm saying 2 comma 3 is less or equal to 3. Okay. If this is the case, then I can simply say 2 is less or equal to 3 and 3 is less or equal to 3 or not.
Yes, sir. Got it.
Maximum of x1 comma x2 is less or equal to a value z, then x1 will be less or equal to z and x2 will be less or equal to z, right?
Yes, sir.
And it's independent, then I can simply split probability of A intersection B is nothing but probability of A into probability of B, right?
Yes, sir. Got it.
Got it. Now it's inside IID, then all the probability will be same. So I can simply say probability x less or equal to z into probability s less or equal to z. Because IID all should be identical, right? So simply it will be probability x less or equal to z raised power n. Now, sorry, 2. N will be for in general. So what's the importance here? If you see, if maximum of 2 or some 3 or some n random variable you have been asked, okay, and you have been asked some c in the form of this case, z less or equal to 3, z less or equal to 4, something like that, then you can simply use the distribution of a single random variable x. I will give you one example for that case. Okay. So similarly, in case of in general, suppose I have instead of x1, x2, I suppose I have n IID. Okay, these all are IID x. Okay, then by using probability of let's say z has been defined as maximum of x1, x2 up to xn. Okay, by using the same concept, probability z less or equal to z, I can simply write the probability of maximum of x1, x2 up to xn less or equal to z, yes or no? Right?
Yes, sir.
The same thing, you can simply use the basic simple concept. Maximum of, let's say 1, 2, 3, 4. I mean, is less or equal to 4. It simply means 1 is less or equal to 4 and 2 is less or equal to 4, 3 is less or equal to 4 and 4 is less or equal to 4 or not. Right?
Yes, sir. Yes,
So
sir.
similarly, I can simply say x1 is less or equal to z and x2 is less or equal to z up to xn is less or equal to z. Right? Now it
Yes,
will
sir.
be all are independent. It will be x1 less or equal to z into probability of x2 less or equal to z up to probability of xn less or equal to z or not. Right? Since all are IID, right? So all the things should be same. X less or equal to z into probability of x less or equal to z. Yes or no? Correct. Since these are n times, so it will be x less or equal to z raised to power n. Is this clear? This here is nothing but fx z of n. Is this clear to everyone?
Yes.
Yes.
Now,
Yes, sir.
let me take one example that will give you idea. Suppose I'm saying x1, x2. Okay, let's say one of these two random variable is following IID uniform 1 to 6. Let's say for rolling a die. Okay, and I asked what is the, and z is defined as maximum of x1 comma x2. Then tell me probability z less or equal to 2. So there is one approach. You can simply do like this: probability of maximum of x1 comma x2 less or equal to 2. Then it will be probability x1 less or equal to 2 comma x2 less or equal to 2. Since these are independent, x1 less or equal to 2 into x2 less or equal to 2. All are ID. Simply I will say x less or equal to 2 raised power 2. Right? Right. So rather than doing these all things, you can simply direct do. I mean, this is the approach you can apply here, right? So what is the probability x less or equal to 2 here? It will be probability x equal to 1 plus probability x equal to 2 whole square, right? And what is the probability for x will take value 1? 1 by 6 plus 1 by 6 whole square. So it will be 2 by 6 raised power whole, that is 1 by 3 raised power. So answer will be 1 by 9. Okay. Is this clear?
Yes, sir.
Yes, sir.
And if x is greater than something, so it will be 1 minus p.
1 minus. Yeah, fine. In the case of maximum itself, see, instead of this thing, so thing is that what you have to keep in your mind, if it's a maximum case, right? Try to convert in the case of less than equal to, because it will be, I mean, you can separate all the terms. Are you getting? If it's a maximum, you can separate all the terms. Yes or no? For example, suppose I ask what is the probability z greater than 2, right? And z is defined as the maximum of x1 comma x2, right? Then it will be little bit difficult to do. So you can simply do 1 minus probability z less or equal to 2 or not.
Yes, sir.
Right? So since maximum case, right? So convert in less than equal to sign, because of suppose I'm saying the very similar case, maximum of 1 comma 2 is less or equal to 2, then I can separate the terms, right? 1 is less or equal to 2 and 2 is less or equal to 2, right? But if it's greater, suppose I'm saying maximum of 1 comma 2 is greater than 1, so we can't separate, right? Correct? So here we can do simply probability that maximum of, you can simply say x1 comma x2 is less or equal to 2. Yes or no? I'm
Yes, sir.
repeating the same procedure. I'm doing this step by step so that you will be having some idea. So here, from here, since it's maximum, I can simply say probability that x1 less or equal to 2, comma x2 less or equal to 2. Yes or no? So it will be 1 minus probability x1 less or equal to 2 into probability x2, x2 less or equal to 2. You can find the probability here, and here you can simply multiply, or else you can simply do probability that x less or equal to 2 is square. Is this clear?
Yes.
Yes, sir.
Now come to the minimum of two random variables, right? Come to that part, minimum of two random. Suppose Z is defined as minimum of x1 comma x2. I mean, case is the same. X1, x2 are some IID with distribution from x. Now, question is probability Z less than Z, for example. Okay. Before going to that, in case of minimum, you can keep in your mind, just go with the greater or equal to sign always. Okay. It will help you. Why? I will tell you. So simply I can write here minimum of x1 comma x2 greater or equal to z, right? Since minimum of 2 comma 3, right? What is the minimum of these two?
2.
2. If I'm writing minimum of these two is greater or equal to 2, then I can split the terms or not. 2 is greater or equal
Yes,
to
sir.
3 and 3 is greater or equal to 2, right?
Yes, sir.
So in case you have to just keep in your mind, if it is a maximum, try to convert in less than or equal to sign, because it will split the terms and a calculation will be very easy. Otherwise, you will miss the cases. Now, if it's a minimum of two random variables or n random variable, convert in the greater or equal to sign, right? So it will be x1 greater or equal to z and x2 greater or equal to z. Yes or no?
Yes, sir.
Since it's an independent case, so I can simply write down probability x1 greater or equal to z into probability of x2 greater or equal to z.
Yes.
Right? Since it's a IID, if it's IID, then I can simply say all the things will be same, right? For both random variables, right? So simply it will be probability of x greater or equal to z raised power n. Is this clear? Okay.
Yes, sir. Got it.
And what about n? N terms, suppose z is equal to minimum of x1 up to xn, then it will be, sorry, it's a 2. Sorry, no one has corrected. So for n, it will be x greater or equal to z raised power n, right? Basically. If it's a IID, if it's a only independent, then you have to stop at this step. Are you getting the difference between IID and independence only, right? If it's IID, sorry, independent only, then you can stop here, because you can't say the marginals are same, right? Yes or no?
Yes, sir.
Now, what's the, suppose in the same case that uniform 1 to 6, suppose I ask probability Z greater than, or suppose I ask Z probability Z less than 2, and Z is defined as minimum of x1 comma x2. Then it's a minimum case, then try to convert as a, then simply 1 minus probability Z greater or equal to 2, right? If this is the case, by using the minimum, so I can simply say minimum of x1 comma x2 will be greater or equal to 2. So just keep in your mind the basic, the very basic thing. If it's a minimum, try to convert in the greater or equal to sign, right? Only then your step will be, I mean, calculation, it will be very easy to calculate. So I can simply say probability of x1 greater or equal to 2 into probability of x2 greater or equal to 2. Yes or no? Now you have to just worry about what is the distribution of x1. So here x1 is some uniform, right? 1 to 6. So here approach is, it's a, so here is another thing. If you now tell me, how will you proceed from here? Yeah, tell me. Whether you will see, there is two things. See, x is taking, x1 is taking 1 to 6 value, right? So here I can simply do probability at x equal to 2 plus 3 plus 4 plus 5 plus 6, right?
Yeah.
Or else I can do 1 minus probability x1 is less than 2.
Yes.
Right? Into 1 minus probability x2 is less than 2.
Yes.
Just to do the simplicity. So it will be 1 minus x1 is less than 2 means probability x1 is taking value 1, only one value, right? Then 1 minus probability of x2 is taking value 1, correct? So it will be 1 minus 1 by 6 into 1 minus 1 by 6. It will be 1 minus 5 by 6 into 5 by 6. So it will be 1 minus 25 by 36. So it will be
9 by
Not 9, 11.
11.
By 30.
11 by 36. Right? Is this clear?
Yes, sir.
Okay. This minimum and maximum is clear. So you have to just keep in your mind that when to use greater or equal to sign, when to use the less than or equal to. Okay. Should I take any activity question, or is this fine? Hello.
Sir, if you will take activity question, then it will be helpful.
Okay, no problem. Okay, let me take any activity. Okay, so let's go with the very first question. That will be fine. Okay.
Yes, sir.
You will be having some idea. Okay, no problem. So the joint PMF table is given to you x and for two random variables, two discrete random variables x and y. Okay. So it says yeah. So if you see Z1 is defined as minimum of x comma y and Z2 is defined as maximum of x comma y. So you have to find the fg of, see, it's a small fz, right? So small f represents for the PMF. Okay. So what do you mean by, sorry, small fz1? So that means probability that Z1 equal to 1, right? See, that is the meaning, right? Z1 is minimum of x comma y and Z2 has been defined as a maximum of x comma y, right? See, the fz1 means this case, right?
Yes, sir.
Okay. So this case
Yes.
z1 equal to 1 means what? Minimum of x comma y equal to 1.
Yes.
Okay. Now we have to just consider all the cases when minimum of x comma y will be 1. See, it's a equal to sign. There is no need to worry about that greater or and all. It's a simply we have to consider all the cases when minimum of x comma y will be 1. So by seeing this value, y taking 1 0 1 2, x is taking 0 1 2 3. Okay, x is 0 1 2 3, y is 0 1 2. So we have to consider all the cases when minimum of these two will be 1. Okay, so when minimum of these two will be 1, when probability of x will take 1 and y will take 1, right? Yes or no?
Yes, sir.
Plus probability when x will take value 2 and y will take
1.
1, then minimum of these two will be 1, right?
Yes.
Okay, let me write down one more step. Sorry. So it's equal to sign. Don't worry about that CDF and all. There is one example question, I think. After that, we will discuss that one. So we are talking about minimum of these two will be 1. So when minimum of, so x will be 1 and 1, right? Or minimum of 2 comma 1. See here, 2 is, this is for x, this is for y. Or minimum of 3 comma 1. Or minimum of, tell me one more value.
1 comma 2.
1 comma 2. These are the only possible cases, right? Correct? Only then minimum will be exactly 1. We are not talking about greater or equal to 1 and something like that, right? We are talking exactly 1. So it will be probability of x will take value 1, comma y will take 1, plus x will take 2, comma y will take 1, plus probability x will take 3, comma y will take 1, plus probability x will take 1, y equal to 2, yes or no? Right? So basically what we have to find, these are the joint values from the table itself, right? So what is the value when x is 1, y is 1? 1 by 12. All are 1 by 12 actually, you can see, right? So it will be 1 by 12 plus 1 by 12 plus 1 by 12 plus 1 by 12, which is 4 by 12, which is 1 by 3. Is this clear?
Yes, sir.
Let's find the f small fg z2 1. Okay. So fz2 1 means what? What is the z2? That is probability z2 equal to 1, and z2 is nothing but maximum of x comma y, right? Now tell me what will be the possible cases? X is 0, 2, 0, 1, 2, 3. Y is 0, 1, and 2. When maximum of these two will be 1?
1, 0.
First of all, 1, 1, 1. 1 and 1. When 1 and 0, correct? And
0,
0, 1.
That's all, right?
Yes.
So all are 1 by 12, so it will be 3 by 12, right? So 1 by 4 is the answer. Is this clear?
Yes, sir.
Okay. Now let's move to the next part. I think, I think by these questions it will be clear. So capital FZ21. So capital FZ21 means what? So capital F basically we are using for CDF. So that means what? Probability that Z2 less or equal to 1. Yes or no?
Yes, sir.
Correct. So this means now you will tell me I can write maximum of x comma y less or equal to 1. Correct.
Yes, sir.
Okay. Now tell me this is the maximum of x comma y less or, since it's already less than equal to 1, right? So I can split the terms.
0, 0.
X less or equal to 1, y less or equal to 1. Yes or no? Are you getting?
Yes, sir. Yes, sir.
Is this clear, right? The same thing we have discussed. If maximum of something is less or equal to something, I can split the terms, right?
Yes, sir. We can.
Correct. Now, since these two are independent, it's given in the question itself. X and Y are independent, if you see. Right. If these two are independent, I can write down X less or equal to 1 into probability that Y less or equal to 1. Yes or no? Correct?
Yes.
Yes, sir.
Yes, sir. Correct.
As you can see, initially we had that IID and all, and we can simply, we did the probability of X less or equal to Z raised power 2 or raised power n. Since this is not IID, if you see X is taking value 0, 1, 2, 3, Y is taking value 0, 1, and 2. By using this case, so what will the probability for this case? So I have
1
to
by 4.
add probability X equal to 0 plus probability X equal to 1, right? Into, for this, probability y equal to 0 plus probability y equal to 1. Yes or no?
Yes.
Now, tell me by using this table, what is the probability x equal to 0?
1 by 3.
1 by.
So basically, x equal to 0 means we have to, it's a marginal PMF, right? So we have to add the first column, right? It will be 3 by 12, right?
1 by 4.
Yeah, 1 by 4 basically. Okay.
Yes.
And similarly, x equal to 1, 1 by 4, right? And y equal to 0, 1 by 3. I mean, we have to add this all the very first row, all the probabilities are in the first row. So it will be 4 by 12, which is 1 by 3. Similarly, y equal to 1, 4 by 12, 1 by 3. Yes or no?
Yes, sir.
Yes,
So
sir.
it will be 1 by 4 plus 1 by 4 into, for this it will be 1 by 3 plus 1 by 3. So basically it will be 1 by 2 into 2 by 3. So 1 by 3, right? We can check the answers. Let's see. Where it went? Yeah, so 1 by 3 is the answer. Correct? As you can see for the previous also is 1 by 4 and 1 by 3. Now come to the fz of fz1 of 1. So by using the same concept, now you people will tell me whether I will check whether you got the idea or not. So tell me how should I proceed? Here z1 is nothing but minimum of x comma 1. Tell me.
Probability.
So I will write probability z less or equal to 1.
Yes, sir.
Now what should I do in next step?
Probability of x less than 1.
Why x less than 1? Now you forgot just a few minutes before I discussed. If
X
minimum
greater than 1.
Greater.
no, before greater than, what should I do?
Probability of x
1
equal
minus,
to
should I do 1 minus probability z1 greater than or equal to 1? Sorry, greater than 1? Yes or no?
Yes, sir.
Yes, sir.
Correct. That was the something I was talking about. If it's a minimum case, right? Try to convert in the greater than sign. Only then you can split the terms for both random variables or more than two random variables, and you will calculation will be very easy. So now it will be 1 minus probability. It's a minimum of x comma y greater than 1, right?
Yes.
Since it's a minimum case, right? I mean, simply you can say minimum of 2 comma 3 is greater than, let's say, 2, correct? Greater than 2. So I can split the terms, right? So I can simply do 1 minus probability x greater than 1 and y is greater than 1.
Yes.
So 1 minus, since this is independent, right? I can do this case, probability of A intersection B is nothing but probability of A into probability of B, right? So
Yes.
probability of x greater than 1 means what?
1 minus p to the power n.
No, don't go with that. You can simply calculate the values because x is taking value discrete 0, 1, 2, 3, right? So x is greater than 1 means we have to add the probability when x is equal to 2 plus probability x equal to 3, right?
Yeah.
And for y greater than 1 means y is taking value 0, 1, 2. So that means probability y equal to
2,
right? So what is the value of probability x equal to 2 and x equal to 3? So x equal to 2 means 3 by 12, then 3 by 12, right? Means 1 by 4 into 1 by 4, right? Sorry, plus into what is the probability for y equal to 2? So it's a 4 by 12, right? We have to
1
add
by
the last row. That is 1 by
3.
3.
right? So it will be 1 minus 1 by 2 into 1 by 3. So 1 minus 1 by 6, which is
5 by 6.
right? You can see 5 by 6 is the answer. Is this clear?
Yes.
Yes.
Yes, sir.
So now minimum maxima is clear to all of you?
Sir,
Huh?
sir, could you please show me one more time?
When? One more time.
That, yeah, I
Okay.
means that last step.
Okay, this one?
Y is equal to 2, means y, x is greater than 1 and y is greater than 1. Then how come it's y is equal to 2 only?
Okay, that's why
Why not?
it's good to focus on the question part with everything. Okay, so if you see y is taking value 0, 1 and 2.
Okay.
Y greater than 1 means y will be equal to 2.
Yes.
Okay, x
Yes,
is
got
0,
it.
1.
Got it, sir.
Got it? Yeah.
Yeah.
That's
Sir,
why I have written here. Okay.
Sir,
Yeah.
sir, I have a doubt, sir. In the first question, when we solved, sir, find f of z1 of 1. In the first question, we are considering 4 cases only, sir. But we can also consider x is equals to 1 and y is equals to 3 also, no, sir? Sir?
Okay.
There's no 3 value.
1 second.
Just no 3.
Is the y is taking value 3?
Yes.
Right? Clear?
Yes, sir. Got it, sir. Got it, sir.
Yeah. So what about, okay, let's do one more question. Let's do this question number 5. Okay, I think 6 you can proceed accordingly. So I will do the question number 5. I think after that we can enter the thing. Okay. So tell me, I mean you will be having the idea, more idea. So here x1, x2, x10. Okay, should we do or is this okay?
Yes, I'll do one more.
Okay, let's do. Okay, let's do. We'll be having some more idea. So x1, x2, x10 are IIT binomial 6 comma half. Anyone can open? Just tell me the value. Okay, let me. So x1, x2 up to x10. These all are IID binomials. See, initially I took in general x, right? So this x is 10. Okay. So Z1 is defined as maximum of this 10. Okay. And Z2 has been defined as minimum of this 10. Okay. Correct? Now, we have to find the calculate probability Z1 lesser than equal to 2. So Z1 is less than equal to 2. So Z1 less or equal to 2 means what? Maximum of x1, x2 up to x10 less or equal to 2? Yes? No?
Sir.
Anything? Since it's already less than equal to sign, I can split the terms, right? Means simply I can write down probability x1 less or equal to 2, comma x2 less or equal to 2 up to x10 less or equal to 2 or not, right? And if all are independent, then I can split the, I mean, I can calculate these things, multiply all these probabilities. Yes or no? Right?
Yes, sir.
Since all are IID, right? Then all the probability will be same.
Yes, sir.
Yes, sir.
Probability x less or equal to 2. Since it's how many times? It's a 10 times. So I can simply say x less or equal to 2 raised power 10 or not.
Yes, sir.
So in
Yes.
the this previous question, you see it was independent only, right? Not IID. Then we calculated, we stopped there and we calculated the for the, I mean, in case of different values and all. It's a IID. Then if it's IID, I can simply multiply it, right? You can see here it was independent, right? X and if x and y are IID, then I can write probability x greater than 1 raised power 2, right? But it was not, correct? So I mean, don't make mistake like independent and you raise to the power something. So if x is less or equal to 2, then how will you proceed? It's a binomial, right? 6 comma half. Then simply I can say we have to add x equal to 0 to 2, right? 6 to x, right? Half raised power x and half raised power 6 minus x raised power 10. Yes or no? See, x is
How
binomial
it is binomial?
6 comma half, right? And x can take value 0 to 6, right?
Yes, sir.
And we are talking about x less or equal to 2. That means you have to add all the things 0 to 2, correct? Are you getting? Yes, no. Everyone is getting this thing, right?
Yes, sir.
Yes, sir, yes, sir,
So
getting
it will be summation of
Yes,
x
sir.
equal to 0 to 2, 6 choose x, right? Half raised power 6, raised power 10, right? So now split the things. That means basically see probability x less or equal to 2 means what? We have to add the probability for x equal to 0 plus x equal to 1 plus x equal to 2. The same thing I have done here. So now I can write 6 choose 0, half raised power 6 plus 6 choose 1, half raised power 6 plus 6 choose 2, half raised power 6, whole power 10. Now, 6 to 0, it will be basically 1. So it will be half raised power 6 plus 6 into half raised power 6 plus 62. It will be 6 factorial, 2 factorial, 4 factorial. So 4 factorial will get cancelled out 50. So half raised power 6 raised power 10. Okay, so basically half raised power 6 I can take common, not common, is basically it will be 1 by 2 raised power 6 plus 6 raised power 2 by 6, 50 raised power 2 by 6, whole raised power 10. So it will be 22, right? Is there any option? Yeah. So 22 divided by 2 raised power 6 divided by, sorry, whole raised power 10 is the answer. Now, is this clear? Correct?
Yes.
Let's do for the minimum case also. I think after that we can. So question is fz2 of 2 and fz2 is nothing but minimum case, right? So we have to find the fz2 of 2 and capital F denotes for CDF. So that means probability z2 is less or equal to 2 and it will be equal to probability that minimum of x1 up to x10 less or equal to 2. Now tell me what should be the next step.
1 minus.
Correct.
1 minus probability of
Correct. Very
then
good.
2.
Yeah, great. So it will be 1 minus probability minimum of x1, x2 up to x10 should be greater than 2, right? So it's a minimum case and it's greater than, I can simply split the probability, I mean values, right? x1 greater than 2, comma x2 greater than 2 up to x10 greater than 2. Yes or no? Now it's a independent, so I can simply write the probability of x1 greater than 2 into probability x2 greater than 2 up to probability of x10 greater than 2, right?
Yes. Yes.
Now all are IID, I can simply write down probability of x greater than 2 raised power how much? 10, right? Yes or no?
Yes, sir.
Right? You can make it the question equation star because you can simply find out this probability separately. How? So probability x greater than 2 That means I can simply 1 minus probability x less or equal to 2, right? I can do or not?
Yes, sir, that's possible.
Right? Just give me a minute. So why I am writing, because to avoid the confusion and all. So 1 minus probability x less or equal to 2, we got the value just few minutes before, right? What was that? 22 raised power 2. This thing, right? For this is the value for probability z x less or equal to 2, right? Only this, not raised power 10. Yes or no?
Yes, sir. Yes.
Correct. So it will be 22 divided by 2 raised power 6, right? Now this thing I can put here, right? This is the value, right? Are you getting my point? What I'm trying to say here? So it will be 1 minus 1 minus 22 raised power 2 raised power 6 whole raised power 10, right?
Yes.
So 2 raised power 6, I think it will be 32 into 2, 64, right? So 1 minus 22 divided by 64 raised power 10. So basically 1 minus 64 minus 22, it will be 42 divided by 64 raised power 10. So now I can write 21 divided by 32 raised power 10. So which will be, is there any option? 21 divided by 32. Okay, so instead of 32, I can convert it into 2 raised power 5. Right? Now, is this clear?
Yes.
Yes, sir.
Okay. Now you got the everyone got the idea behind this minimum, maximum, and all, right?
Yes, sir, got it. But while converting from maximum to minimum, in terms of the operator, greater than less than, that's where the confusion starts. So
No. Just you can keep in your mind, right? See, just you can while you are starting this kind of, just take a very simple value. Let's say minimum of 2, 3 is greater or equal to 2. Then you can simply when I can split the terms when greater or equal to sign will be there, right? Only then I can say 2 is greater or equal to 2 and 3 is greater or equal to 2, right?
Okay.
Just this very basic things we have to keep in mind. That's all. I think it will not create any problem. I think my pages has been finished right now, all 30 pages. Let's say suppose maximum case, I'm saying 3, 2 is less or equal to 3, right? So if it's less or equal to 3, only then I can say 3 is less or equal to 3 and 2 is less or equal to 3, right? With greater, you I mean it's difficult to that separate the terminology, right?
Yes. Okay.
I think, is there any session after this?
M2, I guess.
Yes, sir.
I mean, from 8 p.m. is there any session going on or any other course?
Some maths session.
Oh, okay. Nice. Okay, so I think we have covered all the content with some activity questions of week 2, right? If I'm not wrong.
Yes, sir.
Okay. So everyone got the point?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
then thanks everyone. Okay, we can.
Sir, this was the last session for week 2.
No, there will be one more session on Tuesday, upcoming Tuesday. That will be solved with a session, right? We'll be coming with some questions in slides as we have done in week 1, right? Which will be similar to your graded assignment, and after that, okay?
Okay, sir.
Okay, fine. Okay, then thanks. Hope this session was helpful for everyone. Yeah.
Yes, sir.
Very helpful.
Thanks.
Thank you.
Bye.
Thank you, sir.
Thank you.